Hi guys, so in today's video what we're going to do is going to look at the area of a triangle. Now this is another way of working out the area of a triangle, and we have already seen a fair few up until this point, including the area is equal to a half the base times the perpendicular height. We also know it's equal to half AB sine C, but if we're using coordinate geometry there's a nice other way that we can work out the area of a triangle, and it's written underneath here where as long as we have one of the points being at the origin, i.e. 0, 0, we can use this formula here. Now this is really important, that one of the points has to be at 0, 0. Okay, so if we don't have one of the points at 0, 0, we can't use this formula. However, we can modify our approach to this, and I'll show you that in a second example later on in the video. So the area of the triangle here, OAB, where O is at the origin, remember 0, 0 has to be one of the points of this triangle, is equal to a half of the modulus of x1, y2 minus x2, y1. Okay, remember the modulus just means that whatever happens inside of this sort of like bracket, I suppose you can call it, that if it's a negative or a positive, we just turn it positive. So straight into example number 1 here, find the area of the triangle OAB if O is equal to 0, 0, A is equal to 1, 7, and B is equal to 5, minus 2. Perfect, it's already, you can see here we have one of the points as the origin 0, 0, so we can just substitute this, or substitute the values straight into the formula. So let's just write down the formula, so we know that the area is equal to, and it's a half, the modulus of x1, y2 minus x2, y1, okay, and go and label our coordinates. So I'm going to call this one x1, y1, and this one x2, y2. And all I'm going to do, guys, is just put the numbers in. So a is equal to a half, okay, modulus of x1, and my x1 over there is 1, multiplied by y2, and you can see y2 is minus 2. Then the minus x2, if you have a look, is 5 up there, and y1 is 7. So there we are, that wasn't too difficult. So we're just going to work out these things in the modulus. So it's a half, 1 times minus 2, which is minus 2, and then we've got minus, and 5 times 7 is 35. Okay, not a bother. Work out the modulus bit. A is equal to a half still, and what we now have, minus 2 minus 35 is minus 37. And then to finish it off, remember we said we need to take the modulus, so it's a half, the modulus of minus 37. The modulus is just the positive value of that, so that now just becomes equal to 37, and A is equal to 37 over 2 units squared. Okay, so that's not too difficult. The point was 0, 0, and we just used the formula for finding out the area there. So let's have a look at what happens if one of the points isn't 0, 0. So here, example 2, we've been told that A is equal to 3 minus 1, B is equal to 4, 2, and C is equal to minus 1, 3. And we've been asked to find the area of the triangle ABC. I've just left this up here so you can see where the formula is coming from. And again, notice that we've been told that one of these points has to be 0, 0. If you have a look, I've just very, very quickly sketched this out. A here is 3 minus 1, B 4, 2, and C is minus 1, 3. You can see that there is no point at the origin. Okay, that's not an issue. We just have to do one step before we then work out the area. All we're going to do is we're going to take this shape, this triangle, and we're just going to move it so that one of these vertices, one of these points, is actually at 0, 0. And it doesn't matter which one you pick. I could pick A, I could pick B, I could pick C. But just for this example, I'm going to pick A here, and I'm going to move this to the origin. So in order to do that, I need to go 1, 2, 3 in this direction, and 1 in this direction. And that then will move the A, it's going to translate the A to the origin. Now, if I do that with A, obviously I need to do that with B, and I also need to do that with C, so that the triangle remains the same. So what we do is, I'm just going to write down the points. So I've got A, which is 3 minus 1, B, which is 4, 2, and C, which is minus 1 and 3. And what we'll do is I'll just talk you through it again. So let's go back to A. I'm going to go minus 1, minus 2, minus 3 in the x direction. So I'm just going to write that down. So I'm going to put this in red. So I'm going to go minus 3 in the x direction. And hopefully you can see this isn't too difficult. If I've got minus 3 in the x direction, I now need to go plus 1 in the y direction. So let's do plus 1 there. So plus 1. And just to check, you can see that 3 minus 3 will give me 0, and minus 1 plus 1 will give me 0. So the image now, my new point for this is going to be 0, 0. Now, as I said to you before, because I've moved this one 3 to the left, i.e. minus 3, and 1 up, i.e. I've plus 1, I now have to do this for all of the other points so that the triangle doesn't change. So I'm just going to write underneath that now minus 3 in the x direction, plus 1 in the y direction. Minus 3 in the x direction, plus 1 in the y direction. So now all I'm going to do is get my new coordinates. It's the same shape. It's the same triangle. It's just been moved. That's all that's happened here. So let's work this out. My new A is going to be 0, 0. I'm going to put a dash, because if you see a dash on something, it means the image. My new image of B is 4 minus 3, which is 1, 2 plus 1, which is 3. And my new C is going to be minus 1 minus 3, which is now minus 4. And then what we have then is 3 plus 1, which is 4. I am now of the form, or I'm now of the correct form, in order to just put all of the numbers into the equation or into the formula that we have on the right hand side here. Okay, once we've done that, it's just like we did in the last slide, the last example. I'm going to write down A is equal to a half, and I'm just going to write down the formula. x1, y2 minus x2, y1, all modularized, and I'm just going to stick the numbers in. Label this one x1, y1, this one x2, y2, and off we go. So A is equal to a half of the modulus of 1 by y2, which is 4, minus x2, which is minus 4, multiplied by y1, which is 3, and don't forget to close your modulus. Work it out. A is equal to a half. 1 times 4 is 4, minus, and we've got minus 4 times 3. Minus 4 times 3 is minus 12. Okay, A is equal to a half of the modulus of 4. And what we have here is minus minus 12. So 4 minus minus 12 makes a plus. So that's 4 plus 12. A is equal to a half now of the modulus of 16. Well, 16 is already positive, so it just becomes A is equal to half of 16. And now that means that A is equal to 8 units squared.